Okay, times I post problems that actually cause trouble, and this is one such example, number 5. And what they're asking for is find the values of R such that all the partial sums of this particular series are non-negative. All right, and it says when the values of X are real numbers. So if you look at partial sums, and you could do that, like you write S1 down. It doesn't involve R, by the way, but S1 is just 1/2, certainly positive. If you looked at S2, though, what's that going to be? 1/2 plus R times the cosine of X. Now, one thing you should know about the cosine of X, it bounces back and forth between plus and minus 1. And if I want to make sure this thing is greater than 0, I got to assure this thing here is never going to exceed 1/2. So what I do is I just restrict it between plus or minus 1/2. All right. So what I do over here is I simply say R has to be between plus or minus 1/2. And what does that mean? The absolute value of R is less than 1/2. That's kind of an initial start on S2. Now, of course, I'd hate to keep doing this over and over again, but I do notice a repetitious pattern to this thing over here. So what I do is I write a function down, all right? And I say f of x, looking at it, I'm going to say it's this thing over here, all right? And then what I do is I just look at that and I plug in 2x, and what would you get? F of 2x, I'm just using this function over here and plugging it in. And then 4x, you're just plugging it in here, and you get this thing, so forth and so on, all right? Now granted, someone says, what's this all about? It's kind of write this thing over here, the sum with this functional notation, by the way. So let's take a look at it and see if we have what we need. And I'm looking at it, and again, we're looking at this over here, and I'm starting to see things I want to see, all right? So let's take a look at this over here. What do I see? I see 1/2. This is the sum, by the way. The next thing I see is R cosine X, R squared cosine 2X, which is f of X, all right? I do see that right over here now. Let's look at the next thing I see, which is, R squared cosine of 2X. Well, I kind of see that over here. And I'm looking at this thing over here. And I'm still looking at R squared, right? Let's write that down, all right? This word, it took me some time to get through this. Let me just get my eraser out. And again, we'll kind of look at it carefully now. Let's erase this over here, all right? Let me write down the f of x, the sum again. It's 1/2 plus R cosine X plus R squared cosine 2X plus R cubed cosine 4X plus R4 cosine 8X plus yada, yada, yada. All right, let's look at this again, all right? So I'm going to say over here, kind of just looking at it, I want to write the sum down with this functional notation over here. Let me get my eraser out again. So what do I see? I definitely see 1/2. Now what's f of x? Well, looking at it, f of x is R cosine X plus R squared cosine 2X. All right, so I see that. Let's go to the next one. What do I see the next one? I'm kind of looking at it, and I'm looking for R cubed now, cosine 4X. Well, I'm sort of seeing that over here. All right, so what I'm going to do is multiply both sides of this thing by R squared. And when you get R squared, f of 4X equals R squared cosine 4X plus R4 cosine of 8X. And I'm kind of seeing a pattern at this point, and I see that, all right? So what's that going to be? It's going to be R squared f of 4X, and I see this right over here, all right? Now this is really the part, it's kind of curious what you're looking for. You're looking for a pattern here, all right? I'm going to say over here, just looking at the R's, the first guy over here, R to the 0, R squared, R4. This would be R6. I'm just going up by a factor of 2 each time. And this guy over here, looking at it, X, 4X. What's the next one going to be? 16X. All right. How's that going up? Looks like a power of 2. Right. So let's take a look at that. I should say a power of 4, sorry about that, but it is a power of 2. So power of 4, that would be 4x, 16x, and then 4 times 16x would be 64. 4 times 64 is 256. So I have a generalized pattern over here now, all right? Now someone says, why'd you do that? I guess to write a general derivative down, all right? And the derivative of this thing over here, derivative of f, let's write that down, because I am seeing that. And, you know, what's derivative of f? Again, I'm looking at this over here. It's going to be, let's see, f is r cosine x, r squared. And f prime would be, let's see, minus r sine x. This would be, let's see, 2 would come down. Let's see if I'm doing that right over there. Cosine of 2x. Let me put that down for you. So r squared. The derivative of cosine is minus sine. 2x. And the derivative of 2x is just 2. So I get minus 2 r squared sine of 2x. And by the way, I know an identity for that. It's really minus 2 r squared 2 sine x cosine x. And that's where I'm getting the minus 4 r squared sine x cosine x. All right, what do you do now? Factors. I'm sorry, factor out from that. And get this over here. And then, like I said, certainly no critical value over here, looking at it. And a critical value is where that takes on a 0. And looking at it, you know, the sine function, if I look at this over here, it takes on a 0 every pi, right? So 0 pi, 1 pi, 2 pi. That's where this is coming from over here, all right? So looking at it, you know, yeah, always a tricky thing to do. And I get this f of x, I get its derivative. And looking at it, again, I'm kind of looking at this thing over here and wondering what to do about it. And looking at it, I don't know, maybe factor out. Let me see if I did this right, by the way. F of x, I got that one down. I'm trying to remember what I did with the problem, by the way. Oh, I'm sorry. I plugged in pi k, by the way. And I'll do that over there, the critical value for it. I'm sorry about that. Critical value is this thing over here. You plug it in. And the cosine of the multiples of pi, well, one's there, one's over there. It kind of depends what the power of it is, but it's either plus or minus 1. That's where we're getting this over here. It does depend on n, by the way, r, and this thing over here is going to be, let's see where I got that from. So r squared. You know what? This one's a little bit easier for me to do, and I'll tell you why. It's just going to be 1 each time, so just r squared. All right, looking at this thing over here, and then since r, and by the way, r had to be this to begin that beginning argument. They wanted all the partial sums. I had that restriction over here. And now we got another scenario over here about what the r could be, and I want them to be positive, by the way. And I'm getting this restriction over here now. All right? Again, looking at it, the other critical value, I'm looking at this guy over here. Is this thing over here? A little more complicated to do, isn't it? Yeah. Yeah, but I went through that over here. Again, so that restriction, the original restriction I had over here. I get these numbers over here. And I'm realizing all that analysis, by the way, it's still boiling down to the same thing in the analysis. All right? I found this to be a particularly difficult problem. But the r for this to be non-negative would have to be between 1/2 and minus 1/2. And that was the original premise we came through in the problem, by the way. All right? Now, granted, my goal here is to get you guys to think about this thing over here. I don't think I did the best job of writing it up. All right? Now, again, it took me time to get through it, and certainly I'm not alone in this. But the fact of the matter is someone may see something different over here. And by the way, I did look for different ways of doing this over here. But here's the deal. Maybe you find an easier way of doing this thing. And if you do, you want to share that. And you want to present it. Now, whether you're making a YouTube video or coming to the sessions and explaining yourself, it's up to you. But it would be nice if someone could put a better explanation or clarified mine. Thank you.